Hello, this is the video for the second assignment in the first quiz for the first trimester. An assignment dealing with quadratics in vertex form. So again, you need to have this page of notes handy and the second assignment on this, which looks very much like the first assignment. The difference is now your quadratics are written in what's called vertex form. And yep, you can do a whole lot of work multiplying things out, foiling things out to put it in the standard form, the quadratic form. But we're going to try not to do that. And again, I have 3 problems to show you. And then you can do the rest of the problems in this assignment. Okay, so what you should do is, very first thing, identify whether or not you have the standard form or vertex form. So we do have the vertex form, and A is simply the value multiplied in front of the parentheses. H is the value that's subtracted inside the parentheses, and then K is the value that's added at the end. So you have to think of it in this format, and then you're determining the A, H, and K. And once again, if we're trying to always refer to this, you might have to in the y-intercept a couple of times. You need to use the A, H, and K, like we use the A, B, and C here, to figure things out. But what you should do first is go to a grapher and enter this in +1, and then go to the table and see if you can spot the vertex by looking for that pattern. That pattern never, and I mean never, goes away if you can see it on the table. So if you can't see it on the table, then you have to calculate it by doing the negative b over 2a. So 1, 1 is the vertex, because I see this 0, 0, the -3, -3, the 8, -8, -8. So that 100%, if you see that pattern around that, then you have the vertex point. So -1, -3 I'll use, and I always use the symmetric twin, so 3, -3. You don't have to use the 3 point side. You have to use the vertex. But you could have used -2, -8, and 4, -8. But you have to have the vertex. So all is the same from here. This is going to open down. Why? Because A is negative. And that's this little information that you see right here. And this is going to look like this in the end. So it's one of these 6 that you need to figure out. So vertex is 1, 1. And again, that's the absolute peak or valley point on the graph. And so since this is opening down, it's a peak point, meaning we're going to have a maximum at y equals 1. So that's this guy right here is the y value that goes, and then this is not passable then. Axis of symmetry, x equals 1, so it's the x value of the vertex. X-intercepts, so can we see them on the table? Yes, 0, 0, and 2, 0. It's wherever y equals 0. So what if you can't see that? Then you have to calculate them. You have to go to the quadratic formula or use a root finder, something like that. Oops, actually over here. I'll probably show you the root finder at some point. Y-intercept. So the y-intercept is when x equals 0. So it also happens to be 0 again. Sometimes that happens. So you can write this down when x equals 0 and when y equals 0 on the table, 100%. And so the domain is the same. Always all reals unless we're dealing with something else. So 1, 1, and then 3, -3. and then -1, -3. Factor if possible. I want you to try to figure this out. I'm going to leave that up to you. Every once in a while, I'll leave a bit of information up to you. So notice the top side is on the box here. So that means that the right side of the double inequality is going through 1. Make sure you don't put equal to with infinity, because you can never be equal to infinity. And then so this is less than 1, this is greater than 1. You need to write that in so that you can see it. So as I trace left to right, don't worry about these arrows when you trace left to right. You just trace left to right. So I'm rising less than 1 and falling greater than 1. The arrows help you do the end behavior. So the end behavior is negative infinity on both. That is problem 1. And then I'm going to do 2 and 5, and then let you thrive and do the rest. That rhymes. Okay, once again, this is vertex form. All of them will be vertex form. Oh, that's +5, sorry. And then -4. So you have to think in terms of subtraction. So if that becomes a plus in there, then h is actually negative. And then whatever's on the end, you take that exactly. So it's kind of like the opposite for h and the same for k. Oh, and this, I've been neglecting this the whole time. hk is the vertex. You don't need to even look for that pattern on your table. If it's the vertex form, hk is the vertex. Right there. hk. So 5, -4 is it. And we'll go to the table in a little bit. This is going to open up, which means we have a minimum at y equals -4. Axis of symmetry goes through 5. And now I think we're ready to put this on a table. So x minus 5 squared -4, or plus -4, either way. And so 5, -4 is the vertex. And again, you have to see that pattern above and below like this. If you're not seeing the pattern, you did something wrong. There's no negotiation on that. There is no negotiation on that. And if you don't see it on your table, you have to calculate the x value of the vertex. If you're back on the standard form, the quadratic form. Okay, so you have to, here you can tell from the formula, hk is the vertex. Okay, so actually I should be pointing here for the vertex x value. Okay, so there it is, 1, 2, 3, 4, 5, -4. And then 7, 0, and 3, 0. So notice this symmetric pair of points again, and there's my add. I'm not going to know how to get rid of that, and that's really going to drive me crazy. So I got it free during the first part of the pandemic when school let out, and now, of course, they're probably trying to charge me to use it. Okay, so x-intercepts are 3 and 7. Now, again, we got those because on the table y was 0. If you can't see them, then you have to calculate them. But we could see them on the table. Y-intercept. Let's see if we can go to the table and see it. So that's when x is 0. Actually, you should be always be able to see it on the table. 21. Domain, all reals. Range, it looks like the bottom side of the box here. We can put that in. That's -4, so that's the left-hand part of this compound inequality. Factor if possible. It is possible. Okay, intervals of increasing. So let's go up and put our line through. So we're greater than 5 and less than 5. So we're decreasing for less than 5 and increasing for greater than 5. And then these will both be infinities based on where these arrows end. So the 5s here, back on the intervals of increasing, that comes from the x value of the vertex. So a lot of this is based upon the vertex. So you have to get that right. If you don't get that right, things will fall apart. And then last, problem 5. We'll go a little faster on problem 5. So again, I'm trying to get my act together with my videos. Okay, and again, we don't have, so how do we know that we don't have standard form? Because you'll see the parentheses, you won't see just the squared term, just the x term and the number. You'll see this set of parentheses. You'll see it written like this. You won't see the separate terms here. You can always take that, do the FOIL product out, which there'll be some problems that we do that on later on, and put it in standard form. There's a way to go back and forth, which we're not going to get into now. So this is going to be vertex form 1, 4, and 0. And this is going to open up. And the vertex is 4, 0. So remember that HK, kind of swung and missed on that earlier, that is your vertex all the time. Okay, so 4, 0. And since this opens up, there's going to be a minimum at y equals 0. Again, that's from the vertex point. X equals 4 from the vertex point. X-intercepts just 1 at 4. So remember, you should always be able to look on here. This is going to look like this, where it just hits the x-axis, and when that happens, the x-intercept is the vertex. Okay, so that's another little thing in your little noticing of patterns in math to notice. So to get the y-intercept, go to 0, 16, or you can use the formula on here, a times h squared plus k. That will do it. Factor if possible. Now here's the weird thing. Even though we only have one x-intercept, there's an identical set of factors that get the product. Notice how it's kind of related to that too. It happens twice. Zoom out a little bit. Okay, domain is all reals. It's always going to be the case because I can't get the left and right side of the box on. Let's actually do this now. Let's graph before I 6, 4, and 2, 4. Remember that it is kind of this U-shaped graph. Okay, range. So we have the bottom side of the box, so that means 0 is on the left of this. So 0 less than or equal to y, less than infinity, no top side of the box. Intervals of increasing, so we have to separate less than 4 and greater than 4. That 4 comes from that right there. So we're decreasing less than 4, increasing greater than 4. Once you get this, this is all pretty easy. So this just means where my y values go as the graph gets way to the left and the right. As I'm tracing way out, my y values are getting very large. So just some terminology in mathematics for you. You're taking a pretty big step from your Algebra 1 days to this. So this is interval notation here that we must learn. By the way, if you've noticed, I'm just using a shorthand version, so there's always a way to do interval notation. Do you know that these mean the same? So we know this because the alligator's eating the X. Okay, we know this to be the case because the alligator's eating the 4, not the X. And then you just fill in the other way with an infinity. So every inequality actually can be expressed as a compound inequality. Every single inequality can be expressed as a compound inequality. Okay, and all that means is that you're trying to get in two ends of an arrow. Well, there's only really one end of an arrow, its endpoint, and then the other end goes off to infinity. So this idea of compound inequalities are here to stay, and it's good to learn them, what they mean. Again, the endpoints of this particular, if I was to draw this on the number line, these are the endpoints. If I was to draw this on the number line, those are the endpoints. Okay, so you have the rest of your problems to do.